Hello, everyone. Welcome to another episode of AWS Show and Tell. I'm your host for today. I'm Anil Nadivinti. I'm a senior solutions architect here from AWS, and we're joined by Shreyas from AWS as well. So, Shreyas,
Thanks, Anil. Hey, everyone. My name is Shreyas Subramanian. I'm a principal data scientist and I work on Agent Core.
excellent. Yeah. So, folks, let us know where you're joining from because today I'm joining from New Jersey, and Shreyas is in.
And I'm in Virginia. And the joke is I'm standing on top of all of our data centers, but I'm not.
Well, that's where all the internet traffic goes through, right? I mean, everything in the probably in the world. I think that's probably the where the most of the internet traffic is flowing. That's one of the infographics I was seeing recently.
Yep, yep.
Yeah, and today's episode, we're going to actually talk about agents and how to bring your agents to life, right? So, 2025 has been the year of agents, and what what that triggered is a lot of people across, trying to uh, do some proof of concepts, evaluating how agents fits into their workflows, how that brings value to their customers, right? So the proof of concept phase is done, and now they're looking at how to bring them in front of their customers, right, to be able to really solve those use cases that they're building these agents for. And bringing these agents into production means a lot to do, right, Shreyas? So there is a lot going
I,
on between POC and production.
and I think doing the POCs are becoming much easier as well. So if you have, Cloud Code, if you have, our favorite IDE, Kiro, you can ask it to create a POC agent and it's done in, 30 seconds. So the
Right.
question is like, how would you, take that and then actually put that in production, and show it to your customers and have your customers use it. When your customers use it, it has to be secure. You can't have the same, have two customers have the same access to the back end and things like that. So a lot of real world considerations come in.
Yeah, we have folks joining from Chicago,
Good
Mexico,
city, nice.
Massachusetts, you know, Santa Monica. So we have folks joining from everywhere. But yeah, let's get into the show today, right? So we've had in the previous episode we've streamed how to build those agents, and a couple of weeks back we had Mark and folks also we joined them and showed how to build an agent and deploy it to production using agent core. But
Mhm.
Shreyas, so can you actually give an intro about agent core and how this fits in big scheme of things as we build and bring these agents to life?
Yeah, no, thanks for bringing that up. So, uh, we've talked to multiple customers as well as some internal Amazon teams, and they're building really complex agents. So I wanted to start off with real world use case. We've all talked to a customer support agent at some point of in our time where we're either really surprised that it solved our issue or we're kind of annoyed that it's taking too long. But here's a example multi-agent customer support system, right? So you have obviously on the top you have like a user interface and the data flows down from the top, right? So you have some application front end layer that's like your UI, right?
Hmm.
So this is where you're chatting from. And behind the scenes, a lot of customers architected in this way where you have a hierarchical set of agents. So you have a supervisor agent, which is in blue there. I don't know if you can read the text, but there's a supervisor agent that kind of coordinates back and forth with the user, as well as it has the access to create new tasks for sub agents. So a sub agent could be something that's related to troubleshooting. It could be something that has access to this customer specific information using a database. And the bottommost layer is those tools and APIs that multiple of these agents have access to. So this is, we finished talking about that in 30 seconds, but actually building that could be really complex. And I want to double click that this is not very complex in the real world. In fact, if you went and talked to someone who's actually done this in production, they would say this is super simple. But let's say you had to build this from scratch on AWS. And Anil knows really well that we all like our architecture diagrams, and
Exactly.
the more complex and more colorful it is, the happier we are.
more icons over there, right? So yeah.
Icons. But we don't throw in icons for no reason. All of these icons have a purpose, right? So let's say I had to do this with AWS tools, and of course you can replicate this with any other cloud as well. But usually you would have that front end behind the scenes. You will have to have something like Cognito to authenticate users. You have to have components like WAF to protect from DDoS and malicious traffic. You have a kind of a Lambda function that hits that supervisor agent. Each one of the sub agents have to be hosted somewhere, and you need to take care of those, and you need to manage the instances. Or let's say you're doing this on EKS or Lambda, you need to figure out um, where and how to host that. And then we talked about that lowermost layer, which is the tools and APIs. That usually an entire team sits and just manages those tools and APIs. So it could get pretty complex. And so like getting these agents to production is still extremely hard, right? So and we like calling this undifferentiated heavy lifting at AWS, where we see every customer doing the same thing, right? So they have to solve the fact that my agent is right now some code that exists in my code base or locally on my laptop. How do I put that and host that in a secure and scalable way? Because now I'm expecting tens of thousands of users to come and interact with that
Yeah,
data.
the app could become viral, right? And we need to make sure that the compute is able to support the requirements, and there are all these security constraints or concerns, maybe we should call it that way, right? So those
Absolutely.
are all involved.
And we
um,
like saying like security is job number one at AWS. If it could be job number zero, we would make it job zero.
yeah,
Um, but let's say you have this whole infrastructure that is managed for you, then that becomes much easier to go and host an agent, start interacting with it, deploy it at scale for your expected tens of thousands of users. But let's take a single interaction, right? So a user comes and talks to your agent, and then a few days later comes and talks to that agent again. You want that agent to naturally remember what the previous conversation was. So how do you save that state? How is the agent using this memory? How does the user authenticate and access the agent, and how does the agent authenticate and access the tools downstream? um, so all of these and more are basically repeatedly done, and you have customers with huge teams that are sitting and maintaining this. And if you zoom ahead and calling back to the previous episode that we did that kind of covered the basics of agent core, but we're going to cover a little more again, um, with this kind of simplified architecture diagram. What we think is with agent core, and you're looking at the same complex architecture diagram, but then we have simplified it with agent core runtime as well as other agent core services like agent core identity or memory or gateway. So we're just calling out that today we're talking about runtime, so all of the green boxes here. And then in the same series you will see a deeper dive on agent core memory and gateway and identity. So
so
back
the
to
next
runtime.
Yeah, so the next few weeks we're going to go into the details of each of these services. Today we're going to call out some names of these other services, agent core memory and gateway and identity and so on, right? But in the next episodes we'll have those lined up. So if you're watching, come back in the next few weeks and you'll get caught up on the deep dive series.
Yeah, definitely recommend it. We have folks working on each one of these different services under agent core. But today we're talking about agent core runtime. So let's say your starting point, and a nice way to think about this is your starting point is any framework that you have for agents, right? So it's LangChain, LangGraph, Crew AI, Strands. You might have used any other frameworks as well. So whatever your starting point is, usually these frameworks are kind of the orchestration. It kind of defines how these agents are connecting to LLMs and how are they calling tools and what's this agent loop and all of that. But usually it's pip install a particular framework, and then you can connect to any model of your choice if you were doing this locally. So when we say, with agent core runtime, you can literally lift and shift that. What that would mean for us is you shouldn't have to change any models that you're connecting to. You shouldn't have to change your framework of choice. And this is true in this case. So you could take any starting point, whether that's a way to host an MCP server, and we'll see that today. a way to host an individual tool or an entire agent. So you see all of those variations in there, in the green boxes there, all of which can comfortably sit in runtime, and then you can orchestrate all of these together to have some meaningful thing. And the interesting thing is all of this is fully managed, secure. It is isolated by definition, meaning ground up it's built to be isolated, and it is fully serverless as well.
Right.
So
So
we'll
we'll
talk about all
zoom
this.
into some of these aspects, and Shreyas also has like a some demos today to be able to show how all of these work, and in conjunction with being able to deploy these managed agents, right? So that's kind of the core here, to make sure that you take your POC to go to production, to see what it's going to be like, right? So you need to be in the previous days, when you deploy something to production, if your app becomes viral for whatever reason, right? So you don't know what it takes to on the compute side, and are you scaling very well to meet your demands, right? So these are all the things that are solved by agent core runtime, including security aspects and other things that we're going to see today, right? So over to you, Shreyas.
Yeah, so right before getting into the demo, I wanted to have this kind of main takeaway slide. So if we're 10 minutes in the session now, if you had to take away one thing, then so Agent Core Runtime is a fully managed, serverless offering from AWS where you can securely deploy and run your agents in production, right? And it has some really good or suitable characteristics to what you would need, to go from POC to production. We already said it could be any framework, any model, right? So it could be LangGraph, you could be running a crew AI, crew that is connecting to open AI models. It could be any combination of them. We have a bunch of examples that we'll share. um, the second main thing is true session isolation, right? So, and we'll talk about this in as part of a demo as well, where down to the micro VM level, an individual session is mapped to an individual micro VM, right? So in many other serverless offerings, you will see that this is not a hard security boundary, but we think for data sensitive use cases as well as not so sensitive use cases. I mean, I'm talking about you talking to a customer support agent, you're asking about generic public available information. You still don't want your conversation to be shared with any other customer's conversation, right? So true session isolation, it's built in with identity. So identity and runtime go hand in hand, and we'll have a deep dive session on identity, so you'll learn more about that. The last two things are you could process any payload size up to 100 MB, which is strange and big, and also it could be multimodal input. So it's not only text. And we're talking, and today you'll see all of the demos are text as well, but you should be able to process any multimodal inputs, like send in a large Excel file and say analyze this for the sales for this quarter. And the last thing that we're really excited about is you could do both real time, which means you could stream back in real time, you could do real time sync agents, but you could also do asynchronous agents, which is these agents are responsible for going and doing some task or job for a long time. It could be up to 8 hours on Agent Core runtime, and then you could occasionally check with this because Agent Core runtime recognizes that this is a long running job and will not kill your container, right? Um, so this slide we'll come back to it at the end of it, but this is kind of the main takeaway. With runtime you should be able to go from any framework, any LLM or model of choice that works with agents, and you should be able to securely host it and interact with it using any payload size as well as multimodal capabilities, and it could be real time or async. So let's do that, and we'll shift it up a little bit, and then we'll go into a demo. Uh, and then recalling back for the audience who's returning, we did have a session last time where we talked about the Agent Core SDK, and we talked about how you could use this command line to host an agent very easily and things like that. So we're going to recap it a little bit just for context, and then we'll talk about some more deep dive topics after that. So I think,
Excellent.
yeah, I think we can bring back the
So I'll post the link to the chat as well, in the chat as well, to the blog that has some details here, but here is something that on the UI, on the on the stream. Shouldn't call it UI anymore.
Yeah. So let me expand my text a little bit. Hopefully that's good.
Yep.
Best practice is we want to create a virtual environment locally so that everything is good. So we'll do vn-bin activate, and while I paste in my credentials, Anil, can you pause the share
Yep.
first?
Excellent. I'll do
Just
that. It
I'm going to
is.
paste in my credentials, and I know you are all kind of well behaved and you won't screenshot my credentials, but just in case.
Security.
Yeah. Yeah, and then we can go back to screen share.
Do you want to make that a full screen or?
This should be okay. I
All
think
right.
you can read it. Okay. Um, so the environment already has this agent core CLI built in, right? So if you missed the last live session, so agent core, the Amazon Bedrock agent core starter toolkit has the form of the CLI, and you can do the main steps, which are configure your agent. So just point to what you're going to launch and what that agent looks like, what are the permissions associated with that agent, and then you can do agent core launch, and then you can invoke that agent, right? So those are the main three steps. Once again, like key takeaways, like you have your open source agent, you can configure that agent and then launch it and then invoke it, right? And then we'll talk about the other ones later. um, so what does a good starting point look like? So I'm going to switch to VS Code, and here's an example agent app. Anil, let me know if you can see this all right.
Yep.
um, we have a super simple agent, right? So it's a strands based agent, so we're using strands, and we're going to associate it with a single tool, which is a calculator tool. The way calculator tool is set up in strands is it's a Python REPL. So if you ask it for some complicated math calculation, it's going to create the Python code for this. It'll run the Python REPL, get the response back, and then respond to you. Last time on the previous video, we also shared that it's very simple to transform your existing agents app, whether it's using strands or LangGraph or Crew AI, with a few lines of code. So I'm just highlighting those lines of code here. So we're going to take Bedrock AgentCore Runtime, we'll initialize an app, and then we'll decorate the main function. The interesting thing here is the main function can be a regular synchronous def function, or it could be async def. In this case, we're going to actually start streaming text back, right? So most of all of this is just like, how do you handle the stream? And think of this as you're creating like the server that will now go and be hosted on agent core runtime, and then from outside, from that agent core CLI, you're going to host it and invoke it and then see if the stream comes back, right?
Mhm.
um, so let's do that. So go back to our CLI here. So we're just going to see if we have the right folder. Great. So we're going to talk about like this strands agents streaming.py file, right? So let's do agent core configure, and then we'll give it a name. We'll say this is AWS Show and Tell agent, maybe, and we'll give it this name. And then we'll point dash E basically says this is the entry point, and we'll point to the strands agent streaming.py, right? So immediately it says, please enter your execution role. So the execution role is, it defines the permissions that surround that agent. So it's going to be a container based deployment, and that backend basically has a execution role that connects to, could let you connect to multiple AWS other services. So I'm just gonna hit enter, and that create auto creates the role. I'm gonna auto create an ECR repository as well. It detected that there's this requirements.txt in here, and it says, do you want me to use that for the requirements for this project? And say yes, just enter. And here with authorization, you could do both IAM based auth, which most of you are familiar with, and you could also use OAuth based authorization. So I'm just
Which
going to
means
use,
that could we use the in general like the social providers using that option?
Yeah, so you could have like any IDP, and you can get back a access credential for accessing this agent. And the interesting thing is, it leaves the boundaries of all of the IAM permissions. So you could do it via IAM as well. So while Anil was hiding my screen, I pasted in the credentials that lets me do like AWS actions. So in this case, it'll let me launch as well, right? Um, so the next step, so this is already configured. What it says is you gave it a name. I've detected that Podman is like the runtime, and you can ignore this for now. But essentially, runtime is any Docker daemon. So it could be a Docker. If you have Docker desktop running, be Podman. It could be Finch. It's already detected like the account numbers and the default region and all of that, and it says, okay, the configuration is saved. I'm ready to launch, right? So you can do uh, Agent Core launch. And what this does is basically it uses code build as a default. I don't know if you saw this skip by really quickly, but we just did Agent Core launch, which it's going to go and do a build with code build. So it'll build the container, push to ECR, and keep it ready um, for your hosting. And then you could also build this locally, meaning you want to test this out locally. So you could do dash dash
Mhm.
local, and this will host your agent locally. And this is super important for development. Imagine if you had like a small syntax error in your file, and you hosted it, and then it took like a couple of minutes to host, and then now you're invoking it, and it crashes for some reason, right? So it's super important to um, test locally. So what is happening here is it started the code build, whole actual code build process, and this is going to take all of your files from local. Agent Core Runtime, the CLI, has also created a Docker file for us. So this does not exist earlier. So what this looks like is a basic Docker file. It's just saying I'm going to import from Python, Slim. I'm going to create the requirements.txt, or I'm going to use it to install the basic strands agents and strands agent tools. And then the rest of it is pretty standard. The only thing that I would like to point out is we didn't talk much about observability so far, but what this line does is all of the traces from your agent, and we'll take a look at that as well. So all of your traces from the agent will go to this place in GenAI observability on CloudWatch logs, and you should be able to take that and then look at, okay, here's my invoke coming in. My invoke got translated to strands agents as this particular instruction would then called a tool, and this tool, let's say the tool errored out for whatever reason, and you want to discover that. Those would, a nice visual way to do that is using traces. And once again, we'll have a deeper dive on observability that
So
will
Shreyas,
take you there.
if we zoom out for a second here, right? So what we are doing is that we already have a proof of concept app that we want to take it to production, and
Mhm.
the code base you've created a Docker file, and the Docker file is actually bringing everything together and making a container out of that, right? So out of this build process that you're showing, and Agent Core, the CLI is able to orchestrate a number of these steps, right? So that's what we have been showing so
Absolutely.
far.
And you can do a lot of these manually as well, meaning you could have created the Docker file manually and then pushed using your own CI/CD, pipeline. You could push that to ECR, and then you could, associate an agent, which is what this ARN is a result of. Basically, associating your agent and your code, and which is in your Docker container, which is now an ECR, to an endpoint. And so this agent ARN is associated with an endpoint that you can now invoke, right? So let's try invoking it, and we can continue chatting. So we'll do agent core invoke, and give it like a JSON payload, right? So we'll do prompt. And the reason it's prompt here is because inside the server, code, I'm expecting to get a JSON with a key that's called prompt. So this is not like a special thing. It's exactly what you define in the agent code. And we'll just say hello. So this is invoking AWS Show and Tell agent via cloud endpoint. So this is the cloud endpoint, and you saw it came back pretty quickly, right? So,
Hmm.
and that was a cold start, right? So cold start is where you don't have any servers running and waiting for a request. This has to come up for this request. and then respond with streaming output. And you saw that was pretty quick. Any subsequent requests, and you'll see that the session ID got printed out. And this is where we'll talk about like session isolation a bit as well. So the session ID is a unique pointer to the micro VM that actually hosted your task or your agent in this case. And if I change, let's say I change a character in that session ID, we'll do this in the demo. That would point to an entirely different micro VM that would have another cold start, which is not too bad in this case as well. And remember, this is us doing a network call to a backend system. The backend system is container based. It has to come up. It has strands installed, and so it's not a basic container. It could be like 500 MB. That strands agent is calling Claude Haiku in this case, and then Claude Haiku is streaming back a response to our front end here. So pretty complex, but then it happens fairly quickly. And this is kind of the basic run through. Anyone who saw the previous session, you've caught us all up to the same point where you could use the CLI to really quickly prototype, put things in production, and start invoking and testing, right? In fact, this changes the game of testing in like a real environment as well. So you no longer have to test just the code that you saw here. Typically what we would do is take this code that we just hosted, which represents the actual agent invocation code, and you would just try to play around with it locally. And the only reason you want to do that is because it's too slow to test on the cloud. So we still recommend that you test this locally, because AgentCore CLI also lets you do that. It lets you launch the endpoint locally. But finally, it's also it's really easy to test on the cloud, as you saw in the demo.
Yeah, and Michael, agrees that I think he says you want to be able to test things locally and then amplify that sandbox there. So right on, Michael.
Absolutely, yeah. So let me go back to slide deck for a second, and we'll talk about a few important differentiating characteristics of AgentCore Runtime. So this is a lot of slides, but we're not going to go through all of those slides. We have like a blog that goes through all of this in detail, but I'm going to touch just the points that we think are important to hold on to, right? So we saw that session ID when we did the demo, right? So this is like a UUID. It doesn't have to be UUID; it has to be unique, obviously. But it has to be at least like 33 characters long. And I was pointing out that each session runs in a completely isolated micro VM. So the boundary, there's a hard boundary, meaning you could not, if you wanted to, guess the session ID and try to hit the same micro VM kernel. And this goes down to the like firecracker technology that we have, and so that deploys the micro VM. And it's fully managed by the service, where all you have to point to is, here's my ECR repository, and when I invoke, you use the right permissions to start the container and then come back with responses. The interesting thing again is, if you continued the conversation, and we'll show you that in the demo, and you hit the same session ID, it means the state is persisted there, right? So any in memory objects, any files that you save locally, all of that still exists in that micro VM kernel. And so you can, for example, on one agent interaction, you could say, can you write a CSV file to do something? And with the same session ID, you could come back a month later, and then you could say, okay, can you retrieve the CSV file, right? So not a month later, but a few hours later.
A few hours later, yeah.
But the idea is like a session ID points directly to a micro VM kernel, and the micro VM kernel is a hard boundary. Now, let's say you had to come a month later, and that's what I was going to try to say. If you had to come a month later, then you have to use something like AgentCore memory for out of session state. So this session state can stay on and persist until 8 hours if you keep it alive, and beyond 8 hours it will terminate. 8 hours itself is a pretty long time. If you needed to persist outside, then you would use something like AgentCore memory, where each conversation can be stored as an event in short-term memory. And there's some value adds that when we have the deep dive for memory, we'll talk about, which is let's say you wanted to summarize the user session so far, summarize the user's issues so far. If it's a customer support agent, then you could do something like that with agent core long-term memory. So that's one thing. The second thing we want to touch on is like, what does this life cycle look like? So right now, we have a few regions where you can use agent core runtime, including uh, Virginia, Oregon, Sydney, and you can currently have 500 active sessions. This is a service that's in preview, and so some of these are adjustable. So if you have a real world use case, then definitely reach out to us. On the right side, you see two values. One is a 15 minutes request timeout for synchronous responses, and another one is 60 minutes of streaming. So if you are yielding back some events or
Hmm.
some heartbeat, or if you're yielding back an actual stream of text that you saw in the demo, then that could go on for 60 minutes. Even that is kind of overkill for regular use cases, but we think that might be useful for some folks. So 5 minutes after your session has started, let's say you do nothing. What happens is your session is suspended and it cuts down on your CPU cycle. So you're not paying for any CPU cycles anymore, and all of your in-memory state and your files that you've saved locally are all kind of persisted for the next 10 minutes. So if you go up to the 15-minute mark, that and without any activity, that's when your session times out.
Yeah, this is key
And
to understand, right? Because I think with the pay as you go model, we want to make sure that we are paying for the the resources we're using, and being able to pay only until the 5 minutes, provided the requests are not coming in, is quite important
right,
for
and it
these
gets
agent core
even,
tools.
you're absolutely right. It gets even better, right? So let's say you're running for 10 minutes, and in the 10 minutes, most of your, most of the time, you're actually waiting for the LLM to respond, and maybe a tool goes off and works on something for 5 minutes, right? So the interesting thing with runtime is you only pay for the active CPU usage and memory usage within runtime. So in that scenario where in a 10-minute span, 5 minutes of that is LLM call, 3 more minutes is a tool call, you're only paying for the additional 2 minutes where you're actively using the runtime resources, right? So I think that makes it extremely inexpensive, and you can check the pricing. So don't pay attention to like the unit pricing, because eventually when you put that in an application, then you're actually only paying exactly for what you use, and it's true consumption based pricing. So let's switch back to a quick demo, and we'll see how we can talk about this some more. So we can continue doing kind of the CLI, but I'm going to start a Streamlit app, and Streamlit is a nice way to create like Python front ends, and and you can just interact with it there. So I'm going to start Streamlit, run agent code chat. So I've created this UI. So I'm going to drag it over.
And this is all part of the sample that's on GitHub.
Yeah, and we have an example on GitHub where you can do this something like this. What this one shows is the our agent that we just launched, this AWS Show and Tell agent. It also shows all of these other agents. So you can pick another agent. You can pick a version of that agent, and you could say, for example, uh, say hello again, just to keep things simple. And maybe I can also expand it a little bit. So you saw that coming back really quickly. This is an agent that has access to the calculator tool again, right? The one that we hosted. So you could say, what is 2 to the power of 7? So Anil, are you really quick with math? Can you come back before this one comes back?
Well,
So it came back really quickly, right? That's just a trick question. It's too fast to beat. But you could say something like, did you, you know, this is simple enough for most LLMs. So did it actually use a tool? So did you actually use a tool for this? Um, and what we're going to ask is, this is going to stream back, and it's going to say, yes, I actually used the tool. I'll show you, what call I actually made, and it'll do all of that, right? So the interesting thing is the session ID, like I said. So the session ID, if you changed, one character of this, it's going to completely change. your entire history gets deleted, right? So let's say I completely refresh, clear the chat, and then I say this is obviously a different session ID if you didn't notice. So this is completely different. If I said something like summarize the conversation we had so far, right? So if it was hitting the same session, it would say, "Oh, I see this conversation history," but it says here, "Oh, I apologize, I don't see any conversation history." Even though we're using the same UI, we switched over the session ID, and so now it points to a completely different context. Um, so we wanted to show you like that is exactly what we wanted to show on session isolation. The other thing that's a really important differentiating factor is asynchronous and long running agents. So let me switch back to PowerPoint for a second and go down here.
And we will be, I think we're speaking about this, but I'll just pop up the question. We have
Mhm.
Ritu Singh asking, how does Agent Core enforce session level isolation to prevent data leakage between different agent sessions in multi-tenant environments, right? So we're going to
Yeah,
touch on that.
excellent. Yeah, so I think that's the one we were just talking about, where by definition, Agent Core will have. Let me go back to the older slide to just answer the question as well. So by definition, it's built on top of micro VMs that are physically isolated. So when we did session ID one and we said, oh, okay, like calculate 2 to the power of 7, etc., and what tools you have access to, etc. That was session one. And then we changed the session ID and we said, here's session two or session ID two. It was hitting a totally different micro VM kernel, has no access to the local strands agent object, which means it has no access to the historical, conversation. And we think, of course, for sensitive applications, so if you have customers talking about sending in sensitive files, or they're talking about their account information that an agent has access to via a tool, obviously that's like a no brainer. Obviously it has to be isolated kind of a case. But think of a not so sensitive use case as well. Even there, like session isolation helps. So let's say Anil is talking to the same agent and I am talking to the same agent. The conversation history for both of us is completely different, and I don't necessarily want those to get mixed up in any way. Or let's say the agent writes a file and that's physically in micro VM kernel 1, and let's say Anil logs off and I come in and I want to reuse the micro VM kernel to kind of get whatever file Anil wrote. There's no way for me to do that because I don't have the same session ID and might have expired and things like that.
And also, just to quick recap, is I know when you changed the session ID in the previous screen,
Mhm.
Shreyas, in the demo, right? So in the Streamlit demo, we went there, we were able to ask question, but in true production, we're going to use Agent Core Identity, which is yet another service to make sure that we're authenticating who you are, and we can then at that point only load the session if that belongs to you. All those kind of details things we can do. I think in the demo that Shreya is showing, just to show that these are different sessions. I think that's where he was trying to
Yeah,
highlight there.
and we're going to go from here and build up on this. So, like Anil
Excellent.
said, there will be identity that is associated with the client, but that translates to what the agent has access to and what the tools have access to, right? So, all of that will be talked about in following sessions, right? So, let's talk about async and long running jobs, right? So imagine you had a shopping assistant. And the shopping, usually takes a lot of time. If you sit on Amazon.com or your favorite shopping app, you're not getting done within 5 seconds. It's going to take you like 10-15 minutes to finish your shopping session. But imagine the agent can do this on your behalf. So then this is like a long running, 20-25 minute deep research agent that will go back and search for products on your behalf. Let's say you're looking for a new smartwatch or something like that. And it comes back, 20-25 minutes later, has to come back and say, oh, okay, I'm done with my research. Here's my, final report. And these are very typical nowadays. We see both synchronous kind of agents as well as asynchronous agents. And what we're showing here as a kind of a fictitious use case with a shopping agent is that you might have an agent that responds quickly back to you. That's kind of the client facing agent. But that client facing agent might talk to a background tool or a background async shopping agent that runs for a very long time. So Let me show you what that would look like in actual code, right? So we'll go back to the VS Code. Give me a second. Yeah. So here's another, strands agent. This looks simpler because we're not actually streaming back responses. It's going to be like synchronous responses. So all I had is like this main function. I did the same exact thing with, wrapping around with the at app.entryPoint decorator that comes from AgentCore Runtime. And all I'm doing is passing whatever payload that comes in with the prompt key. I'm going to pass it into the agent. So what does the agent do, right? The agent has access to two tools, right? So it has access to the start background task tool, and then it has access to, another tool that says what background tasks are actually running, right? And this background task tool, on purpose, I've kept it simple. It's just a async sleep function, right? So it'll go back and say, let's say you want to start a background task for 100 seconds. It'll sleep for 100 seconds, but then imagine if you did that in the normal way, right? So if you don't do it in a thread, then you will not get a response back to the client. So what will happen now is when we say, start the background task for so many seconds, we're going to start a task, and then we can continue chatting with the agent and say, is there something still running in the background? Is there like a long running task that's running? And the interesting thing with Agent Core is that all of this happens, with the magic of this add async task, right? So when we have that app context, which is the Bedrock Agent Core app, we're going to say app.add async task, and that creates a background async task. And then you can, whenever you think it's complete. So let's say in the shopping case, it goes out and shops for 15 minutes, and you can define when the actual task completes. And that's when your Agent Core app has registered that this task ID, which was associated with this once with the long running task that started, has completed, right? So all of this to show you what the code looks like. It's less than 40 lines of code or
Is
so,
is this as simple as creating that background task, right, to be able to spin it up?
and that's it. So it's just, app.add async task, and then once you're done, you should complete your async task. Otherwise, your agent core behind the scenes, it's sending out a ping that's healthy busy. So it's saying back to the service, don't kill me, I'm still busy doing something, and so let me run. So that's what it's saying. But let's go back to maybe the UI. We have one that agent. I've already launched it, and it's called Strands Async. And we'll refresh the session ID. We'll clear the chat, and we'll say, "Can you start a background task for 100 seconds?" Right? And this is not something that you would typically. This is for a demo. But then usually you'll have an actual background task that takes some undetermined period of time, but you should be able to detect when it's done, right? So you can even do, let's start multiple background tasks, right? So this is, I'm going to copy that in. I'll say start another one for 200 seconds.
Hmm.
So it'll go back, and then so what we're expecting is, since that backend container can be multi-threaded, we should see both background tasks. And if you notice here, it says, and we're using the same session ID, it says I've successfully started another background task. So it's like continuing the conversation. It's not like you're doing one and done, and I'm
Hmm.
doing some kind of trickery in the front end. So we'll say, what tasks are still running. So let's say
So
you came back.
yeah, if you're building like a travel agent, like one is searching for weather, another searching for hotel deals, flight deals, right? So everything is.
Absolutely, absolutely. So it says, okay, here's this first task has been running for 49.4 seconds in this 100 second task, and the second has been running for this. And so what this means is you're still you're accessing the container, but behind the scenes there is more tasks that are running that can asynchronously complete, and then you can come back with a report or something like that. So things like data analysis, the travel agent example where it has to research multiple options, things like that. Here's where like agent core runtimes, async, and long running tasks can help. And like I said, this can go on to up to 8 hours, and we think 8 hours is plenty for most use cases. But yeah, if you have some really crazy but interesting use cases, reach out to your AWS team. We're super curious to know what that is. um, the last major topic I wanted to touch on is MCP servers. And by way of introduction, so if you're not very familiar with MCP, then MCP is a standard protocol that was it's now open. It was started by Anthropic, but MCP lets you connect in a standard way to multiple tools and APIs, right? So imagine you had like these three tools here. You had like one to add numbers, one to multiply numbers, another one to do something else. I will show you the code version of this as well. Then you could do this with separate APIs. But imagine you had like a team, team one is building a few agents, team two is building a few more agents, and they all want to reuse the same capabilities. Then it makes sense to create that as an MCP server so that agents and now frameworks have all kind of evolved to support MCP. And so you will have direct first class support for, having a MCP client connect to a MCP server in the backend, which then exposes some tools in a safe way, right? So with Agent Core Runtime, you can do zero changes to your code. So if you have MCP server code that's running, you have created that using fast MCP or the MCP SDK or TypeScript MCP, you can take that and then do the same things that we did in the original, configure, launch, and invoke. With the exception that it's not like you're invoking an agent anymore. This is for having authenticated access to tools behind the MCP server. So on the right, you're seeing a typical tool that many people use is called MCP Inspector, and you should be able to use this locally. But the interesting thing is, if you host a MCP server on Agent Core Runtime, you should still be able to access it, provided you have the right access, right? So I'm gonna, instead of playing this, we'll go back to
See
the
this live, right? Yeah.
yeah, we'll go back to the demo actually. um, and maybe we will start MCP Inspector. All right, so you see MCP Inspector, and it's already pre-filled with this long ARN, which is actually a MCP server that I've already hosted. As you'll see, there's like a few recognized transport types. We're going to be using streamable HTTP, which has now become the standard for remote MCP servers. If you have something local, then you will very frequently see STDIO used. And this is a use case for a local MCP server would be something like you have Cloud Code or you have VS Code, and maybe a coding agent has access to an MCP server. You could also do that locally with Agent Core. But the whole idea is now you have something that's sitting out there as a cloud resource, and then you can use streamable HTTP to connect to this actual runtime. And remember that nothing is running now, so it's all serverless, meaning it'll only start running once I start accessing it, right? So on purpose, I'm not going to talk about this yet. But imagine this was just I could paste this link in the chat and people could try it out, right? So which would not be very secure. So I'm going to try to connect to it as though I just did that. And this bearer token is basically something that I've pasted in that has an expiry for 60 minutes. 60 minutes is a lot. So in practice, we want you to have it much lower. But for demo purposes, this bearer token is the access that is the authorization that you provide to hit that serverless MCP server. And you saw that it got connected pretty quickly. So this is a serverless MCP server, and we're going to do, for example, list tools. And we saw from the slide as well, we saw this is the tools that are existing. So you have add numbers, you have multiply numbers, and MCP inspector is a nice way to test these things. And just to show you that it actually works, we'll do something like AWS Show and Tell audience, right? And we'll run this tool, which is basically just going to come back really quickly. And you saw that was once again a cold start, right? It'll come back with hello AWS Show and Tell audience, nice to meet you, great. So the idea is, this is a nice way to test, but in production, how would you use it, right? So you would have maybe an Agent Core runtime container that's talking to another runtime container that has MCP server, or maybe you have other local agents that are talking directly to MCP servers. So that's another major thing that you could just take, lift and shift to to Agent Core Runtime, and it just makes it easy because there is no additional code that you have to write. So let me switch back to the code. This is the actual code behind that entire server demo, right? So this is the entire MCP server. There's nothing behind the scenes, or it's not calling like a sub function or sub folder or anything like that. We had the add numbers, we had multiply numbers, and we had the greet user. These are all dummy tools, but imagine you had like a real MCP server that you can host on runtime and then start using. So I'll go back to maybe I'll show a little bit of the console as well, Anil. So let me bring up the console and then show you how you can explore some of these agents on the console.
Yep, yep. Let's do that.
So I'm going to drag this over so that I can share. All right. So let me show you. One thing I wanted to show you was the code build, right? So you see all of these builds that we were doing. So this agent core builder, which basically, if you go into one of these build projects, you'll see the actual full run of the build. Where this is when you're using the agent core CLI, it's actually using code build to build and push the container to ECR, right? I'm going to switch to also Oregon before going to Agent Core. So you can search for Bedrock AgentCore. And like we said, today we're only talking about runtime, where you deploy and host these agents at scale. The follow-up sessions will be about gateway, about memory, about identity, and built-in tools as well. So if you go into runtime, essentially you see all of these different agents. Today, the agent that we launched was AWS Show and Tell agent, right? So you see that. We also took a look at streaming and the Async agent and the MCP agent. So if you go into any one of these, for example, let's go into like the streaming agent. You see a bunch of nice details that we made use of already. So this is the ECR image URL that the image of that particular agent is sitting in. It was created obviously today, but if you go down to the invocation code, it gives you some examples of how you can actually invoke this agent. We did this with the CLI, and we also did this with the Streamlit app, which is behind the scenes. It's using something like this, which is the Boto 3 APIs. So I wanted to point out as well, we showed the CLI and didn't really talk about Boto 3, but obviously all of the supported granular actions that you can do with Agent Core are available in the Boto 3 API for Python users. What you see here is also super interesting. So there is one default endpoint, and this default endpoint is associated with the latest version, which is version 2. So if I made a code change and then I did Agent Core launch again, it will automatically update the version to version 3. And then the default version will point to version 3, right? So that's how it works. And then if you look at, so what I clicked on, if that was too far, is fast as I clicked on the observability or view observability, it should take you to CloudWatch. And CloudWatch has a nice new tab called GenAI Observability, which is in preview. So it shows you a bunch of different things. Once again, we'll have a deeper dive on observability coming up. But I just wanted to show you, all of these agents in this agent view that we were talking about. So the MCP one, this is another one using a different framework called ADK. This is the one we launched today. And then the streaming and the async one, right? And if you go to the sessions view, you should see, multiple sessions, so different session IDs. And then you can also see a bunch of traces related to many of these agents, right? So for example, maybe we'll pick one that's slightly longer.
You've been doing all these trials on running agents for a long time, I
Yeah,
guess.
don't look at my don't look at my multiple traces, like 288 traces. But the nice thing is it works out of the bat. You don't see me, do anything with hotel and telemetry and things that should just work out of the bat. As long as you're using Agent Core Runtime, all of this gets fed back into GenAI observability behind the scenes, and you should see these nice trace details, right? So here we're seeing the MCP one. but you can see it for the other agents as well. And you can see, this is defined as a span. And for example, in another example, you might see an agent calling a LLM, coming back and then calling a tool, and then once again calling an LLM before responding to the user. So that would be a typical trace. Um, so let me go back to the slide, and if we have any questions, Anil, happy to answer there as well.
Yeah, sure. I think we have one question from Abhijit, but this is on agent core memory. Abhijit, we're going to do an episode on memory. We're going to dive deep into that. Meanwhile, I'm going to paste a link to the blog. You can find all these details here. And this is about, are we going to store the memory, history, and chat context, right? So that's what Abhijit is asking us.
Yeah, definitely tune in for the memory deep dive. But just to answer the question here as well, so we said like for out of state persistence, you can use short term memory and long term memory, right? So the short term memory, think of it as a way to save the turns between user and assistant, or it could be any sort of namespace. But the easy way to imagine it is user and assistant. And then the value add there that Agent Core Memory brings is the asynchronous processing of those events. So if you just had it as pure events, you could do it anywhere. You could do it in DynamoDB, you could do it on S3, pick your poison there. But if you look at what Agent Core Memory in the long-term memory space offers, it's like, let's say I've been talking to that customer support agent, and then for a admin on the customer side or on the provider side, essentially, you want to see what were the issues this customer face, summarize this conversation, or what is the next best action. So those kind of things are value adds that we see customers doing repeatedly that are solved nicely using memory. And once again, stay tune in for the memory session. That'll be even more interesting. Yeah.
Right. So yeah, we're getting to the end of the session. We have a couple more minutes, but Shreyas, let's try to see what we have. The couple more slides that you're trying to show us.
Yeah, the one thing I wanted to show also is, we talked about, here's this agent core app decorator magic. And, some customers are uncomfortable with some of this magic SDK that we do. But I wanted to point out that as long as you follow this contract, which is have a slash ping in your server and have a slash invocations, where your slash invocations is the main business logic. You can call an agent, you can call a tool, you can put whatever you want inside the slash invocations post method. As long as you have this API contract, you could pretty much host whatever you want in Agent Core runtime. But it's most suited for agents and tools and MCP servers because of the characteristics that we'd like to call back to, which is session isolation. You could take any framework, any model, and host it on runtime. You could do long running asynchronous jobs like we saw in the background task example. And you could send in any payload up to 100 MB. It could be multimodal. It could be, a couple of Excel files, for example, or a few images of receipts. And finally, all of these are kind of takeaways for Agent Core runtime, but we should say it works well with all of the other Agent Core services. Like memory was one question that came up, and has embedded identity. Also works with gateway. We'll talk about, and observability we saw a little bit of as well. So
Nice. Yeah. So great details here on runtime. Right. So audience, if you're just looking to deploy your first agent and go for the managed way of doing it, there's more that we're going to cover in this series.
yeah,
Uh,
if you're having to hire a big team or write more than 4 lines of code outside, if you're not using agent code, then something's wrong. So definitely consider taking a look at our examples and also the deep dive blog that we have on the AWS blog channel.
right. Cool. Yeah. So with that, we'll see you again in the next episode with another topic on agent core in the deep dive series. And with that said, that's it from our side. Uh, so we'll see you again next time.
Thank you.